Hello everyone, welcome to iQuanta. Good evening Khushi. Hello Aniket. So this is going to be our fourth session on CAT before CAT as well as on number system, right? And you can see the schedule here. First session, second session, third session, fourth session that we are going to have today. It is based on factorials and other miscellaneous concepts. And then we are going to have some practice on these questions. I hope all of you guys are enjoying these sessions and learning something every day. Okay. Hello only cat. Good evening. I'm good. Quiz किधर हो रहे हैं? I guess खुशी quiz is happening in CAT preparation Facebook group. Okay. CAT preparation Facebook group. Check that group. Okay. So once more I will tell you about iCat 7. iCat 7 is live now and there are lots of prizes that you can grab. First prize iPad, second prize 10,000 cash, third, fourth, fifth prize you can get IMABC batch for free, that is good, and then more prizes, right? So it's really important that you attempt this test. It's free for everyone. You just need to go to iQuanta.in and you can write this mock test. All right. So let's start with our session today. Hello, Sanya. Good afternoon. So if we talk about factorials, what is the meaning of factorial? 0 factorial is equal to 1. 1 factorial is equal to 1. 2 factorial is equal to 1 into 2, which is equal to 2. 3 factorial is equal to 1 into 2 into 3, which is equal to 6. 4 factorial is 1 into 2 into 3 into 4, that is equal to 24. 5 factorial is equal to 1 into 2 into 3 into 4 into 5, that is equal to 120. In short, we can also write 6 into 5 factorial, which will be equal to 720. 7 factorial will be equal to 7 into 6 factorial, which is 5040. So basically you can say n factorial will be equal to 1 into 2 till n, right? Product of all of these is known as n factorial. All right. Now till 7, if you know these values, it could be quick when you are solving these questions. Otherwise you will have to calculate. Okay. But till 7 factorial, these are important numbers. Now in case of factorial, what we can say, if I am writing 10 factorial, 10 factorial will be equal to 1 into 2 into 3 into 4 into 5 into 6 into 7, 8, 9 and 10. So if I prime factorize this number, if I write the prime factorization of this number, the power of 2 will be equal to 8. The power of 3 will be equal to 4, power of 5 will be equal to 1 and power of 7 will also be equal to 1. Power of 5 will be equal to 2. Okay. So what we can say, that highest power of 2 that can divide 10 factorial is equal to 8, or we can also write it that index of greatest power of 2, which is also known as IGP of 2 in 10 factorial. Both of these are same thing. Highest power of 2 that can divide 10 factorial is equal to 8, or index of greatest power of 2, which is IGP of 2, that in 10 factorial will be equal to 8. Now in case of IGP, we can generalize and we can create a formula. What is that formula? That I will tell you in the next slide. In this slide, if you have any doubts, then let me know. Okay. बताओ है कोई डाउट? हेलो अकुल, गुड आफ्टरनून. आयुष्मान, गुड इवनिंग. गुड आफ्टरनून है या इवनिंग? गुड़गांव में तो इवनिंग हो चुका है काफ़ी पहले, सुबह से ही इवनिंग है गुड़गांव में, दिल्ली में भी मौसम ऐसा हो रखा है ना। Sanya, see, power of 2, if you check the power of 2 is 1 here, 4 can be written as 2 square, right? 3 can be written as, 6 can be written as 2 to the power 1, 3 to the power 1. 8 is nothing but 2 cube, and 10 is nothing but 2 to the power 1, 5 to the power 1. So, what will be the power of 2? Power of 2 will be 2 to the power 2 plus 1 plus 3 plus 1. So, 2 plus 1 plus 3 plus 1 कितना आ रहा है, और एक ये 1 छूट गया. This will be equal to 2 to the power 8. We can say that 10 factorial is divisible by 2 to the power 8, right? 10 factorial is divisible by 2 to the power 8. So, we can say highest power of 2 that can divide 10 factorial is 8. And in different language, we can also say that, language is English, in different way, we can say that index of greatest power of 2. Means if you prime factorize 10 factorial, what will be the highest power of 2? It will be 8. Is that clear now? Why 0 factorial is equal to 1? 0 factorial is an exception in case of factorial formula, okay? Chalo. Now, what's the formula? So, IGP of prime number P, IGP of prime number P in n factorial will be equal to greatest integer of n by p plus n upon p square plus n upon p cube and so on. Okay. So, if I want to find what will be IGP of 5 in 100 factorial. So, this will be equal to 100 upon 5 plus 100 upon 5 square. Now, if you take further, 5 cube is greater than 100, so we do not need to take it. This will be equal to 20, this will be equal to 4, that is equal to 24. That is equal to 24. That means 100 factorial can be written as 5 to the power 24 and rest of the factors, or you can also write it as 25 to the power 12 and rest of the factors. So, IGP of 25 will be 12. So, if you need to find IGP of any number in any factorial, you will have to use the prime factors of those numbers. Okay. So, using this formula, you can only find the IGP of any prime number in n factorial, not for any number, not for composite number. All right. IGP means यहाँ तो लिखा है copycat, only cat. IGP means index of greatest power. ये देखो, index of greatest power of 2, which is same as highest power of 2. IGP means highest power of any number. All right. Okay. So, now on the basis of this, let's try few questions. Let's try this first one. How many values can natural number n take if n factorial is a multiple of 3 to the power 33, but not 5 to the power 43? Option D. What's the exact value? Shayak, Ayushman, what's the exact value? If it is none of these, then how many values are there? Can you tell me the value? This question says how many values can natural number n take if n factorial is a multiple of 3 to the power 33 but not 5 to the power 43. So, first we will have to find the smallest value of n for which the IGP of 3 is 33. Can we say that? So, what is the minimum value of n? Minimum value of n for which IGP of 3 is equal to 33, because after that if you take any value of n, the highest power of 3 will be 33 or greater than that, right. So, how do you find, this is 33 is equal to what? We need to answer this question first, right. So, how do we jump to this value? So, there is no direct formula to find the value of n where you can direct value of n where you can find this, but I will tell you one very direct concept. What is this? Number is 3, the prime number is 3 and the IGP is 33. So, multiply 33 into 3 minus 1, this gives 66. Let us check it. IGP of 3 in 66 factorial is equal to 66 by 3, 22, 22 by 3, 7, 7 by 3, 2 plus 1, which is equal to 32. Means 66 does not give us 3 to the power 33, right. So, this is not valid. So, we will have to check the next multiple of 3. What we can say? IGP of 3 in 69 factorial, because in 67 factorial, 68 factorial, power of 3 will be same, which is 32. So, IGP of 3 in 69 factorial will be 23 plus 7 plus 2 plus 1, which is equal to 33. So, for this we can say if you take n is greater than equal to 69, then for all the values of n, it will be divisible by n factorial will be divisible by 3 to the power 33. Okay, it will be divisible by 3 to the power 33. Now, let us check for 5 to the power 43. What will be the minimum? Now, let us check for 5 to the power 43. So, 43 into 5 minus 1 is equal to 172, right. So, let us check IGP of 5 in 172 factorial. 172 by 5 is 34. Yes, 34 by 5 is 6 plus 1, which is equal to 41. So, we will have to check the next multiple of 5, because this value is not valid. If you take n is equal to 172, you do not get it. So, IGP of 5 in 173 factorial will be not 173, next multiple of 5, which is 175, will be equal to 35 plus 7 plus 1, which is equal to 43. So, what we can say that n should be less than equal to. So, from here what we can say that n should be less than or equal to 174. So, what is the range we get for n? N should be greater than equal to 69, less than equal to not equal to sorry yes less than equal to 174. So, number of values is equal to 174 माइनस 69 प्लस 1 कितना हो जाएगा 105 106 राइट, दैट्स योर आंसर 106. Now how many of you knew this method that instead of doing hit and trial, if you want to find that what will be the IGP of any prime number p in n factorial, you should start from here and then you won't have to do hit and trial. You can get the actual value very easily, right, very easily. As you can see, if n is greater than equal to 69, then all the values of n which is greater than equal to 69, it will be divisible by 3 to the power 33. Now if n is 175, then 175 factorial is divisible by 5 to the power 43. Means if I take 144 factorial, it won't be divisible by 5 to the power 43. So n should be greater than equal to 69, but it should be less than equal to 174, है ना. What's wrong with 69? 69 by 3 is 23 plus 7, है ना, plus 2 plus, अच्छा plus 0 होगा यहाँ पे ना, अच्छा सॉरी माई मिस्टेक, वेट ए सेकेंड, यहाँ पे भी नहीं आएगा, सॉरी, this will be equal to 29 plus 2 31 and this will be equal to 32. Okay, we will have to check next value 72 factorial. So this will be equal to 24 plus 8 and plus 2, which is equal to 34. Okay, so n should be greater than equal to 72. N should be greater than equal to 72, है ना. This will be 72. ठीक है. So 72. So 175 minus 72, 103. अब ठीक है, 72 तो काउंट कर सकते हैं ना, तो 71 करेंगे यहाँ पे. हाँ ठीक तो है, ठीक है, सेम थिंग, 103 इज द आंसर. अब ठीक है ना आयुष्मान, 103 होगा ना आंसर, 175 माइनस 72. ठीक है. All right, chalo, let's go to the next question. In which position from the right is the first non-zero digit present in 578 factorial? Tejaswini, we don't need to prime factorize 578 factorial. Okay, we just need to understand that when you expand 578 factorial, there will be some numbers and it will end in few zeros, right? It will end in few zeros. So how many zeros will be there? If we find that, then just after these zeros, there will be one digit, right, which is non-zero digit. So if there are n zeros, answer will be n plus 1. So how many zeros will be there? How many zeros will be there? So at the end of any number, how many zeros are there? 1000 can be written as 10 cube, because it has 3 zeros in the end, right? 12,500 is 125 into 10 square. So it has 2 zeros because power of 10 is 2. So we just need to find what is the total power of 10 in 578 factorial. right? So what we can say, that we need to write it as 10 to the power k into m in this form, right? And what is 10? What is 10? 10 is nothing but 2 into 5. So if we find the power of 5 in 578 factorial, we will be able to find the power of 10 in 578 factorial. So what we can say, IGP of 10 in 578 factorial is same as IGP of 5 in 578 factorial. The power of 5 and the power of 10 will be same, right? Why? Because there will be lots of 2's here as well, and all the 2's multiplied with all the 5 will give us the 10, and this will be equal to 578 by 5 is 115, right? Then 115 by 5, 23 by 5, 4. So that is equal to 127, 142. That means 578 factorial can be written as 10 to the power 142 into m, where m is not a multiple of 10. So answer is 143rd digit, 143rd digit from right will be non-zero. 143rd digit from right will be non-zero. Okay. So Akul got this correct, Ayushman got this correct, right? Sanya got this correct, Subh not correct, you know. Only Cat got this correct. Subh, Sumit, is that clear now? Tejaswini, is that clear now? Batao. If you need to find the power of 10 or number of consecutive zeros at the end of any factorial, what do we find? We find power of 5 or IGP of 5. Now, let us try this one. If the last 3 digit of the number a factorial minus b factorial is 600, then find the maximum value of a plus b. Okay, Akul. Although you are missing a really good question, try this one, or if it's not urgent, then you can go after this. 11. Avi, Krishna, Gaurav, Siddhant. What are the values of A and B you are getting? Can you tell me this? What are the values of A and B that you are getting? 720 minus 120, and that's the last of it. Is it not possible that we can get any better? Think about this. See, 6, 5 factorial, last 3 digit. We are talking about last 3 digit. So, this will be 120 in case of 6 factorial, 720 in case of 7 factorial, last 3 digit. We are talking about last 3 digit, it will be 040. 8 factorial, last 3 digit will be 320. 9 factorial, last 2 digit will be, so multiply this by 9, so this will be 0 and कितना हो जाएगा 9 into 8 and 27 plus 1, 8, right? And then 10 factorial will be ending with 800. 11 factorial will be ending with again 800 ही होगा ना. 11 factorial, what will be the last 3 digit of 11 factorial? So 11 into 008, so 008, ये भी 88800 से ही end करेगा. What will be the last 3 digit of 12 factorial? So 006, 12 into 6 is 9600, 12 into 8 is 96. Then 13 factorial will end with what values? So 13, 3 into 6, 8, 800. 14 factorial will end with 200, right? And then 15 factorial will end with 3 zeros, right? Now think about this. If we are looking to find last 3 digit as 600, right? So if value, if A is greater than equal to 15, means 000, then in one of the, if I am taking 000 minus something 400, then only I am getting 600, right? But none of these factorials have last 3 digit as 400, है ना? None of these factorials have last 3 digit as 400. So this case is not valid. This case is not valid. So let's start with the maximum. Okay, 15 factorial and onwards we cannot take. If I take A is equal to 14 factorial, so what will happen? 14 factorial is 200 minus 600, then we will get 600, right? Can we say this? Meaning, if this value is 14 factorial, I should choose a number where last 3 digit is 600, right? And this is what? This is what? This is 12 factorial, right? So in that case, we need to take as this as 12 factorial, and if you subtract this, the last 3 digit will be 600, है ना? That's it. That's it. As we know that we don't need to take any value of A which is equal or greater than 15. So I take maximum 14. Last 3 digit of 14 factorial is 200. So last 3 digit of B factorial should be 600. So the maximum value of B that we can take is 12 factorial. In fact, no other values are possible even, right? So our answer is 600. Is that clear now? Right? Now, can you tell me this? Can you tell me this? If instead of this 600, I make this 400, okay, then what will be the answer? Batao. Instead of 600, if I make this 400, then what will be the answer? Yes, answer for the previous question is 26, right? Answer for this question is 26. This is the answer. 27 गलत है. 27 देखो, I consider two cases. What if a is greater than equal to 15? If a is greater than equal to 15, if a is greater than equal to 15, a factorial will be equal to 0 0 0 ending with 3 zeros. So if I take a value of b factorial, this should end with 600, and in that case the difference will be ending with 400. So 600 maximum I can take is 12. But a could be any number. A could be any number greater than equal to 15, right? 15 factorial, 16 factorial, 100 factorial, 1000 factorial. Last 3 digit of these factorials will be 000. And if you subtract 400 to this, you are always getting 600, है ना? कितना अच्छा क्वेश्चन है. कौन सा बेटर क्वेश्चन है, ये वाला या अभी जो किया वो वाला? फर्स्ट 600 वाला या 400 वाला? राकेश, मिनिमम 2700, मिनिमम 27 ऐसा है क्या? मिनिमम कितना होगा? हाँ, ये आ जाएगा, है ना? मिनिमम कह सकते, हाँ कह सकते हैं, शायद मिनिमम 27 हो जाएगा क्या? 600 शायद, है ना? 400 वाला, है ना? अगर उस क्वेश्चन को सही से फ्रेज किया जाए, सही से बनाया जाए तो काफ़ी अच्छा क्वेश्चन बन सकता है. चलो, लेट्स ट्राई द नेक्स्ट वन. फाइंड द प्रोडक्ट ऑफ द लास्ट 2 digits. लास्ट 2 digits. अच्छा, ओनली कैट, एक बात बताओ कि इस छुट्टी के दिन में यूट्यूब पे आधे घंटे से तुम हो इसी के लिए ना, कि ऐसे क्वेश्चंस मिले जो परेशान करें, राइट? इसी के लिए हो ना, कि कुछ मज़ा आए सॉल्व करने में, समझने में, है कि नहीं? अदरवाइज़ कौन अपनी छुट्टियां बर्बाद करता है कि नहीं? राइट? Chetan, I missed your doubts. See, just for an example, 1200 minus 600 is 600, right? 2200 minus 600 will be ending with 600, last 3 digit, है ना? 1325200 minus 866600, ये भी तो एंड करेगा 600 में, समझ रहे हो? चेतन, I missed your doubt, now I saw that. ठीक है, I hope you got this. Find the product of the last 2 digits of 51 to the power 147 into 33 to the power 240. So whenever you find that any number unit digit is 1, finding the last 2 digit of those numbers is very easy. देखो, last 2 digits, okay, let's refer this as LTD. ठीक है, Let's say we need to find the last two digit of 91 to the power 86. Last two digit of 91 to the power 86. Unit digit will be 1. Unit digit will be 1. Now, if you want to find the second last digit, multiply the second digit of the base and unit digit of the power. 9 into 6 is 54. This 4 will come here. So, last two digit of this number will be 41. Let's say what will be the last two digit of 71 to the power 88. ठीक है, क्या हो जाएगा ये? यूनिट डिजिट विल बी 1 एंड second last digit of the base and unit digit of the power. 7 into 8 is equal to 56. This 6 will come here. So, last two digit of this will be 61. Using that we can say last two digit of 51 to the power 147 into 33 to the power 240 will be equal to last two digit of 51 to the power 147 into last two digit of 33 to the power 240, which we can write, this will be straight away 5 into 7 is 35. So, ये 5 आ जाएगा into इसका last two digit क्या होगा? Can I write this 33 square? What is 33 square? You don't need to find that. Last two digit of 33 square will be same as 17 square, which is 89. So, 89 to the power 120, right? Now, 51 into last two digit of, still the unit digit is not 1. So, let's take square again. What is the square of 89? I don't know, but I know that last two digit of 89 square will be same as last two digit of 11 square. 100 minus 11 is 89. 11 square is 21. So, it will be 21 to the power 60. So, 51 into 2 into 0 is 0, 0, 1. That will give us 51. ठीक है, that's your answer. Using this method, okay, you can directly solve lots of questions where last two digits are involved, है ना? Avi Krishna, yes, there are lots of shortcuts to find last two digits, but I am using the generalized method. Using that, you can find last two digits of any numbers, है ना? Last two digits of any numbers. 5 क्यों होगा? अच्छा, प्रोडक्ट चाहिए क्या? फाइंड द प्रोडक्ट ऑफ लास्ट टू डिजिट्स ऑफ, हाँ ठीक है, फिर तो 5 into 1 is equal to 5. दिस विल बी द आंसर, करेक्ट है ना? सिद्धांत, लास्ट टू डिजिट्स सी 33 स्क्वायर, 33 to the power 240 can be written as 33 square to the power 120, which is equal to, it's 1089 to the power 120. ठीक है, तो इसका लास्ट टू डिजिट ही लो, तो 89 स्क्वायर to the power 60, which is equal to, what is 89 square? 11 into 2, 22, 78 plus 1, 7921. So, 7921 to the power 60. When we are finding last two digit, we are only going to consider last two digits. So, 21 to the power 60, unit digit will be 1, then 2 into 0 is 0. So, second last digit will be 0. That is why last two digit of 33 to the power 240 will be 0, 1. Okay. All right. Although guys, in any number, अगर कोई odd है, पावर 20 या 20 के मल्टीपल है, तो लास्ट टू डिजिट 0, 1 ही होगा. ठीक है, कोई भी नंबर, ठीक है, कोई भी डिजिट, कोई भी नंबर जो odd है, यूनिट डिजिट odd है, except 5 of course. So, last two digit will be 0, 1. But again, then you will have to learn other methods as well to find the last 2 digits. But what I am telling you, you need to use only one method to find the last 2 digits in any case. In case of even, it's 76 rule. Yes, that is correct. All right, let's try this one now. Aniket, it says in the question the product, find the product of the last 2 digits of, ठीक है. So whatever the last 2 digit of this product we are getting, we need to find the product of the digits, find the product of the last 2 digits of this number. So last 2 digits of this number will be 5 and 1. So multiply those. So in this question, if n is the sum of all distinct 6 digit numbers that can be formed using each digit of 432 exactly 2 times, then find the remainder when n is divided by 7. So we have smallest such number will be 2, 2, 3, 3, 4, 4, right? And then largest such number will be, we can also write 2, 2, 3, 4, 3, 4, right? So ऐसा ही चलता जाएगा 4, 4, 3, 3, 2, 2. How many numbers will be there? Number of such numbers. So there are 6 digits. So 6 factorial arrangements are possible. 2 is used twice, 2 factorial, 3 is used twice, 2 factorial, 4 is used twice, 2 factorial. That is equal to 90. Now think about this. At unit place, 90 digits will be there. At unit place, 90 digits. Out of those 90 digits, 2 will come 30 times, 3 will come 30 times, 4 will come 30 times, right? And same for every other place, right? At tens place 2 will come 30 times, 3 will come 30 times, 4 will come 30 times. So if I add all these numbers for unit digit 30 times unit digit will be 2 plus 3 plus 4, and the position is 1, the position value is 1, so 1, so plus, then at the tens place 30 times 2, 3 or 4, but tens place if you are talking about this 4, this is not 4, this is 40, so we will have to take 10 plus 100 plus 1000 plus 10,000 plus 1 lakhs, यही होगा ना, देखो 5 zeros, this will be equal to 30 into 9 into 11111, so that will give us 270 into 11111, right? So this value will be equal to, what will be this value, है ना, क्या होगा, 0 हो जाएगा, 27 into 1 is 7, carry 2, तो 9, कितनी बार 9 आएगा, so 5 times 9 और एक बार 2, 299999970. What will be the remainder when this number is divided by 7? So देख लो डिवाइड करके, 28 19 14 59 56 39 then 49 then 70, so remainder is equal to 0. ठीक है, this is how you can find the total sum, but there is a shortcut as well. See, there are 90 numbers, right? The smallest number will be this, the greatest number will be this, and all the digits will be used in cyclicity. All the digits will be used in cyclicity. What does that mean? Means every digit will be used equal number of times. So you can directly find the sum. Total sum is equal to total number of numbers by 2, take the minimum possible plus maximum number possible, 45 into, it will be 66666, which is the same value, 2 5 times 970, है ना. ये एक बहुत अच्छा शॉर्टकट है टोटल सम फाइंड करने का, if all the digits have been used equal number of times. Okay, for that you don't need to use any permutation and combination or anything else or any lengthy calculation. All right, chalo, let's go to the next one. Try this one. तो इस क्वेश्चन में ज़्यादा दिमाग नहीं लगाते, इस तरह के क्वेश्चंस में डायरेक्ट पैटर्न चेक करना है. इफ़ यू टेक 2 into 22, this will be equal to 44. If you take 22 into 22, this will be equal to 484. If you take 222 into 22, it will be 4884. Then 2222 into 22, this will be equal to 48884. So each time 1 8 will decrease. What is the sum of the digits? This is 8. This is 8 into 2. This is 8 into 3. And this is 8 into 4, and so on. If there are 4 2's, sum of digit will be 8 into 4. So what do we have? 222 39 times into 22 will be equal to 48884. So sum of digits, you can check the pattern, it will be 8 into 39. 390 minus 78 is 312. So that's your answer. Okay. So whenever you have a big number, so always try to check the pattern there. You can find the answer much easier in that way. It's 312, not 308. Okay. Now let's try this one. This is an interesting question based on remainders. None of these. Find the least positive integer value of a so that 7 to the power 89 plus a is divisible by 15. So if I find Euler of 15, this will be equal to 15 into 2 by 3 into 4 by 5. So that is equal to 8. Euler of 15 is equal to 8. Using the Euler's theorem, we can say remainder when 7 to the power 8k is divided by 15, the remainder will be equal to 1. So what will be the remainder? Remainder 7 to the power 89 divided by 15 can be written as remainder when 7 to the power 88 into 7 to the power 1 is divided by 15. 88 is a multiple of 8. So 7 when divided by 15, the remainder will be 7, right. So if the remainder is 7, this gives us a remainder of 7. This number must be 8, right. This number must be 8. So our answer is option D, which is 8, right. You can also check in the power of 7, that 7 to the power 4 is equal to 2401, which gives us a remainder of 1 when divided by 15, right. So in that case, 7 to the power any multiple of 4 will give us a remainder of 1 when divided by 15. So you can also not use your Euler's method and solve this question, right. So Euler's Torsion theorem says that if m and n are co-primes, then remainder when m to the power k into Euler of n is divided by n is equal to 1. This is the Euler's theorem, where k is a whole number, where k is a whole number. This is the Euler's theorem. Yes, arithrocyclicity can be used as well. I have mentioned that 7 to the power 4 is equal to 2401. So yes, that is correct. Okay, Rakesh, this is the Euler's Torsion theorem. M to the power k into e to the power n, when divided by n, the remainder is 1. Euler's of 15 is 8. So 7 to the power 8 or multiple of 8 when divided by 15 will give you a remainder of 1. It is 89. 89 can be written as 88 plus 1. So 7 to the power 88 will give us a remainder of 1 and then 7 for the rest. Euler's कैसे निकाला? देखो, यूलर निकालने का मेथड, इफ n इज इक्वल टू a टू द पावर x, b टू द पावर y, c टू द पावर z, द प्राइम फैक्टराइजेशन ऑफ n इज दिस, देन Euler of n is equal to n into 1 minus 1 upon a, 1 minus 1 upon b, 1 minus 1 upon c and so on. Okay, this is how you find Euler's of any number. ठीक है. All right. So this is how you find Euler of any number. All right, everyone. So don't forget to write iCat 7, as I have mentioned yesterday as well as today at the beginning of this class, that don't forget to attempt iCat 7, and which is live and it's free for everyone, and there are lots of prizes that can be won by writing iCat 7. Okay, so very less time is left. Okay, you have time till 11th of August. In that time, if you are able to write iCat 7, you get good scores, there are prizes. All right, so you can go to iQuanta.in and check iCat 7. Apart from that, iQuanta last batch has started last week. Only 1 or 2 classes has happened in every section. So if you are looking to crack 99 plus percentile in CAT 2025, then you must join it. There are lots of discounts going on. So you can again talk to our support number, you can get that discount and join us. Last year, most of our students, from all the 500 students who got 99 plus percentile, were from last batch. So that's an amazing information. So if you are joining last batch, if you are joining now, it does not mean that you cannot get that magic number, right? So join iQuanta and get 99 plus percentile. Okay. So, yes Radhika, it's free for everyone, alright. So, that is it for today guys. Let us meet in the next session very soon. Thank you for joining us. Bye bye.